What's up everyone, and thank you for choosing to learn with LAM. Today we're going to be going over empirical formulas. But first, let's quickly discuss the difference between an empirical formula and the chemical formulas we've been using so far, which are called molecular formulas. Molecular formulas tell you the exact number of atoms of each element in a chemical. So glucose has a molecular formula of C6H12O6, meaning that it has exactly 6 carbons, 12 hydrogens, and 6 oxygens. An empirical formula, on the other hand, is the simplest ratio between the elements in a molecule. So for something like glucose, we could simplify the 6 to 12 to 6 ratio by dividing everything by 6, which would give us a 1 to 2 to 1 ratio. So the empirical formula of glucose would be CH2O. Now it is important to be clear that CH2O is not glucose. It is just a formula that represents the simplified ratio of elements in glucose. The equations that we're going to be using today are the mass percent equation and the mass to moles equation. As always, links are available in the description below if you need to review those concepts. Now, typically, when you're given an empirical formula problem, you'll be given the percent composition of the unknown compound. So in this case, we'll be finding the empirical formula of a compound that has a percent composition of 50.91% zinc, 16.04% phosphorus, and 33.15% oxygen. And I'm just going to line them up like this because I feel like it keeps everything nice and neat. So first things first, what are we going to do with these mass percents? We know we're looking for a ratio of elements, so the safest bet would be to find moles. In that case, we probably want to start by converting these mass percents to masses, and we'll do that by assuming that I have 100 grams of my sample. Because we're looking for a ratio, it doesn't really matter what total mass I assume, but I'll do a sample calculation with zinc so you can see why I chose 100 grams. We're going to rewrite our mass percent equation with the information given, so 50.91% equals the partial mass of zinc divided by 100 grams times 100%. I'll divide both sides by 100%, which cancels out my 100% and gives me 0.5091 equals the partial mass of zinc over 100 grams. And now I'll multiply both sides by 100 grams to isolate for the partial mass. That gives me 50.91 grams as the partial mass of zinc. Notice that because I assumed that my total mass was 100 grams, the number value for the partial mass is the same as the mass percent. And that saves me quite a bit of work. As I said, the ratio is going to turn out the same regardless, so we might as well pick a total mass that's easy to work with. So now let's fill in the masses for phosphorus and oxygen. And at this point, I have the information necessary to find moles. I'll do another quick sample calculation here for zinc. If I want to find the moles of zinc, I'll use the mass to mole equation and substitute in my knowns. So moles of zinc equals 50.91 grams divided by the molar mass of zinc, which is 65.41 grams per mole. And that gives me 0.777 moles of zinc. Let me just write that again up here, and I'll do the same thing for phosphorus and oxygen. Do notice that I'm using the molar mass of each individual element here. Alright, now I've got the mole ratio of my various elements, but those aren't exactly the prettiest numbers. So what we'll do is divide all the moles by the smallest number of moles, and that will get me some bigger, more usable numbers. I end up with 1.5, 1, and 4. Now, usually all the numbers do end up being whole, but sometimes you'll end up with these 0.5 guys. Getting rid of them is easy. We just multiply every number by 2, which gets rid of the 0.5, but also maintains the ratio. And now I can take these numbers, put them into my formula, and create my empirical formula, which is Zn3P2O8. By the way, some of you might recognize that this would be more appropriately written as Zn3 bracket PO4 bracket 2, which is zinc phosphate. But because we're only looking for ratios, this is fine. Also, you may find that sometimes the empirical formula is the molecular formula in cases where a molecular formula can't be simplified, and that's fine also. but we'll discuss molecular formulas more in the next video. As always, if you have any questions, please leave them in the comments. Good job, everyone. If you find that you need a little extra help, please feel free to check out my other videos for tips and tricks on how to succeed in school. And as always, thanks for learning with LAM.